So if you're comfortable with the Python basics, right? So we'll be using most of them now. Right? We have briefly spoken about classes and objects. So that also we'll be seeing it here. But that's okay. For understanding these things, the understanding of Python object-oriented programming is not really required because it gives a kind of intuition of what is happening. Right. Having said that, for the next topic is Paramiko followed by NetMiko. These are the Python's utilities or libraries, right, to talk to remote devices so that we can automate tasks on the remote devices. So that was our ultimate goal, right? To be able to automate remote system configuration. Right? So the first topic is Paramiko, which is a Python library. It's nothing but a Python implementation of our good old SSH. Right? How we used to connect to remote devices, we just used to do SSH using SSH, that is a secure shell. And then we used to log in either using username, password, or keys, right? SSH keys. And then we used to connect to the system and then be able to perform different operations. All of you are familiar with how SSH works? Anyone who is new to SSH? Yeah, for logging into remote devices. Okay. So basically, how SSH works is, I mean, it's a protocol, right? If two networks are reachable or identifiable over a network, we can establish SSH connectivity between them so that they talk to each other over a secure shell. Right? Normally, we log into the devices, we get access to its shell. SSH uses something known as secure shell, right? For obvious reasons, which means any communication that takes place is encrypted. Right? Now, to be able to SSH to the other device, you have two mechanisms. One is either you can use username, password, the standard way of authenticating yourself, or you can use something called as SSH keys. Right? They have provided this SSH keys because every time, let's say you do not want to keep entering your password, username or password, right? In such cases, you can set up SSH keys, which means you authenticate once and continue. It's like SSH keys are a way of establishing trust between the client and the server, that is the machine from which we are doing an SSH and to the machine to which we are connecting. Right? Now, these SSH keys are somewhat like your it's like a two-way trust mechanism. Right? Let's say you have this bank locker facility, right? I'm not sure if all of you are from India, but in your respective countries also you'll have a similar thing, right? You have a bank, you have an account with the bank, you want to utilize the locker facilities. Yeah. Okay. So you have two keys. Right? Every locker will have two keys. One is with the banker. Other is with you. Right? Correct? When you want to access your locker, you have to go. Both these keys have to be matched. How do you go when you want to go and access your locker? How do you go? You take the key which is with you. Then what does the banker do? He takes the key which is with him. He puts them both in the locker, which means he matches those keys. That's when the locker will open. Right? Exactly, it's the same principle which is used in SSH. So when you generate SSH keys using a utility called as SSH keygen, which is part of OpenSSH server utility, most of the operating system come pre-installed with the OpenSSH server. If not, we can always install it. Right? This OpenSSH server has something known as SSH keygen. Right? SSH keygen will generate these two keys, one private key and one public. The one with the banker or the one which is with the party that we want to connect to is public. Right? We keep our key with him, and we don't know who will be having it. Right? Today that guy, tomorrow some other employee. The one which we keep with us is private key. Right? Now same way here, you have a server. Right? That is the host to which we want to SSH. And client. Some of my keys are not working. Right? The machine from where we are doing SSH. So we generate these keys, keep the public key with the server. Right? Which means somehow you have to go and put the public key on the server. And then whenever the client is going, he goes along with the private key. He carries the private key along with him. Then on the server matches both this public key and private key. If both are matching, it allows. Okay, that's how it happens. And another small thing that happens is, right, the server should, the server, on the client machine, right, when you talk to the server, it's like the SSH algorithm, which is the SSH client, which is running on your system. It says, do you trust this guy? Because you are trying to connect to this guy over an SSH secure protocol. Do you trust this guy? Right? So only if you say, yes, I trust him, then it allows you to go ahead and connect. Now the thing is, it will keep asking every time you want to connect, it will keep asking, do you trust this guy? Do you trust this guy? Do you trust this guy? So instead of it keep on asking every time, we say, okay, I trust this guy, add him to the list of my known contacts, right? Add him to my list of friends. So there's a SSH maintains a file known as known hosts. So the entry of the server's some signature is generated in a some hash which is generated for the server gets added to known host. So that next time onwards, when we try to SSH, it checks first known host. So does this guy exist in known host file? If yes, he is a trusted guy. You can go ahead and SSH. It is outside of the public key private key mechanism. Okay, these two things that happen. port is not, port is 22 by default. Okay. So let me show you. For example, I have my terminal. Right? So by default, there's a .ssh folder in our user directory, and this file, known host file, will be there. So let me open this known host file. There's so many. Let me just one of them for now. Okay, this is what I'm talking about. Right. The first time I tried to SSH to this, let's say this host, it says the authenticity of this host could not be established. So it has generated a key fingerprint for this host. He says, I'm going to, are you sure you want to continue connecting? Right? If I say yes, this entry will be added to my known host file. So that time onwards, this thing will be prompted. So we say yes, I trust them. Go ahead and connect. Right now, if you see this known host file, right, this entry is made for that host. Right. So that is the first thing. The second thing that happened here is, you see, I said, okay, connect to this guy, SSH username @host. It didn't prompt a password. That's because I've already established that public-private keys mechanism. Right? So these are two things. Okay. Now, why I'm explaining all this is that's what these are required to understand some of the parameters that we use, some of the additional things to Python. Okay. Now that we did that, let's jump in. Okay. They are there in your .ssh folder. Right? There are different algorithms which we use to generate. For example, ED25519. This is the latest and very safe algorithm. Otherwise, we were using RSA standard. Right? There are older algorithms also, but RSA and ED25519. These are the more standard and more recent algorithms for generating these keys. Right? Obviously, if you're generating these keys, it should be a secure mechanism, because if the keys can be broken, if the keys can be decrypted, then secure. So these algorithms also keep changing. It was RSA. Some other algorithms were there. Then RSA came. RSA was being used for quite a while. Now ED25519 is becoming more popular. So if I do like SSH keygen -t, that is type ID and this ED25519. And then I can add some comments, some text to remember for which I'm generating these keys. Right? When I do this, it will generate two keys. Right? ID underscore the algorithm name. You see here it is ID underscore ED25519 and ID underscore RSA if you use RSA mechanism. One without the extension, without any extension, the other one with extension .pub. .pub, as the name suggests, is the public key. The same name, file with the same name without any extension is the private key. Okay, this is where they get stored. Now we have to take this public key, go and put it on the server in a file in the same location called as authorized keys on the server. I'll show you by connecting. This is the server I've connected, right? I've landed on the home page. I'll do cd dot authorized keys. I know. So this is the algorithm. This is the public key that I've added. SSH ED something something, my mail ID. Since I added this, it's like I left my key with the server. When I'm going, I carry this key. Okay? This guy is sitting with the server. When I'm going, I take this key and both are matched and I'm allowed. Which server I'm using is just a Ubuntu server. Okay. Yeah, these are the things that will happen. Now, when I connected, my entry is made into this known host. So that's why next time when I'm trying to connect, it is allowing me without prompting. Okay. Now let's say I delete this entry again. Again, it will prompt. Okay. This is what keeps happening. Every time it gets added, and then I delete it. Again, you try to connect. Again, it prompts you. So this you keep in mind. Let's go to this guy, parameter. Now, whatever I've shown you, what I've connected to is a Linux device. The same principle applies for network devices as well, right? Network hosts as well. Right? You have to establish public-private key mechanism with the network host, add the public key to the network device, and when you are connecting, you get a prompt. Do you trust that guy? Signature will be added. It's virtual. Whatever you see, it's everything virtual that's being used. Okay. Yeah. So before we can start using, we have to, obviously it's a third-party library which is not available, which does not come with Python installation. So we will have to do install, right, using something known as pip. Right, it's a Python library, and all Python libraries can be installed using something known as pip. We said pip install Paramiko. Now this pip guy knows where to go and look for this Paramiko library. Right, he goes to something known as PyPy website, a kind of online registry which is hosted on the web, where all the people upload their open source work. It goes there and this thing. It depends, pip or pip3. It depends. I mean, if you already had Python 2, if you're on Mac or Linux systems, if you already had Python 2, then Python and pip, these names are reserved for your Python 2 executables. In such case, Python 3 and pip3 will be used for your Python. Right? So you'll have to see whether your Python executable is called as Python or Python 3. In that case, your pip becomes pip3. Right? So first you try pip. If it says pip is not recognized, then you use, or if it is using version 2s, then you'll have to use pip3. The other standard way is using is pip is also one of the modules of Python, right? So instead of using it directly, because there could be multiple versions of pip installed, what we'll do is we will use Python executable -n. We'll tell Python to fetch this pip library from the right location. We'll say Python -m pip, and then the rest of the command is same. Install what is the package that you're trying to install. This is a more standard way of using pip, but you're free to use just this as well. Okay, in my case, it is already installed, so it says requirement is already satisfied. Everything is in place. Module. M is to say that yes, I'm instructing my Python executable to look for a module called as pip and then use it to install Paramiko. Okay. Now once I install Paramiko, I can start writing my code. I have to import it. Import Paramiko. Once I import it, what is the first thing that we will be doing? We'll be creating an SSH client, right? which means now we are in the programming world. We are in the scripting world, right? In the script, I need a guy who represents my client, who will do the job for me, right? So I'm creating that guy. I'll call him as SSH underscore, let's say CL client. Right? This is a variable. This is a Python variable I'm creating, so I can name it whatever I want. This guy will be paramiko dot SSH Paramiko has Paramiko is a library. He has a class, the Python object-oriented programming class that we have seen called as SSH client. When an object of this class is created, what I get is logical representation of an SSH client. Okay, so we say client is equal to paramiko dot SSH client. Now this SSH client is like this guy. Like now I got this guy from my Python. Now when I go and try to do SSH for the first time, he gets prompted, right? He gets prompted like this, right? So to take care of this in a programmatic way, obviously my program cannot halt here, and it cannot expect me to enter yes or no or fingerprint, right? So what we do is, what Paramiko guys have done is, okay, when you are faced with such situation, automatically add the key, right? This guy is coming with this key. Automatically add it to known host, right? Every time you take this, which means it's a way of saying, okay, I trust that guy. Without prompting me, let me go ahead. So I'll say set missing host key policy. Set missing host key. Like if the server which I'm trying to connect to, it's not in my known host, then automatically add it to my known host and go ahead. So that's what this function does. Right? You get a client. This client has this function called as set missing host key policy. Which policy to be used? I'm saying auto add, but go ahead and add automatically. Okay, that is the meaning of this line. So I'll say SSH underscore client dot set underscore missing underscore host underscore key underscore policy. You see how patiently they have taken time to name their functions in such elaborate manner without using any cryptic keywords. So this is a recommended program, a way of naming your things, be it variables, functions, etc. And that's very clear, right? Okay, what it is talking about. Set missing host key policy. We have to decide, use some policy to deal with the situation which I have shown. How to deal with that situation is, Paramiko package has a policy called as auto add. I'm saying use that. Auto add policy says that yes, when you are faced with this kind of situation, go ahead and say yes. What happened to my connection? Anyway. Okay, that's what this line means. Now that is done, I will have to tell which device I have to connect to. For a moment, assume that I do not have my keys set up. I'll be using username and password mechanism, right? If I have my keys set up, well and good. Suppose my keys are not set up, I'll be using password mechanism. So I have to define my device. What is the host name? What is the username? What is the password? You see how I'm defining those variables? I'm defining them inside what is this? I'm defining connection parameters inside a Python data type known as dictionary. Yes. Okay, this is a Python dictionary. So I put my details in a Python dictionary so that I can pass this entire dictionary to the connect method. Now this you remember, star you have seen, star you have not seen, but star you have seen, right? When you are writing a function and you want to pass some variable number of parameters, you don't know whether you want to pass 1 value, 2 values, 3 values, 4 values, right? You put a star saying, I'm going to send you, I don't know how many number of variables. Any number of variables I send, you should be in a position to handle. That's what this means. The second star means that, okay, I'm sending you a dictionary. You break this dictionary and take this first key and value, send it as named parameters, which means this connect guy expects hostname, username, password to be passed with those values, right? So this star says that take this dictionary, break it down, go inside, take these values and pass them as key value pairs. So that's what this means. And then I have to say which port to connect to. And then I have to say something else. Right? Now this I have to say look for keys is equal to false. Now here I am specifically saying look for keys is false, which means default value is true. Right? So the connect method, SSH client's connect method is okay. Okay, let me show you. Let me take this dictionary, or let me type it down. Okay, till here I have taken care of this guy, right? My client from where I'll be SSHing. Now I have to define my device, the remote device. What is my host name? What is username? Now these names are fixed. These names have to be like this: host name, username, and password, as per the Paramiko documentation. You can check Paramiko documentation. It expects you to pass, in case you are using, let's say, password-based authentication, it expects you to pass minimum 3 values: host name, username, password. Well, Shashank, so we normally keep the questions to end so as not to have too much of disruption once we get into the details. So try if you can type it. If not, maybe you can just note it down and then we can discuss it. If it's urgent, maybe you can ask it here. Now I need to pass this guy SSH client. I need to take this SSH client and then say connect to this guy. What are the details to be used? These details. Okay. Now if you pass this dictionary as it is, this method is not defined, is not designed to break it. Now somehow I need to go inside and I need to take these details, right? Device.hostname, device.username, device.password. That's the way we access the keys of we access the values of a dictionary using their keys, right? That is a manual way. If that has to be done automatically, Python has a way to break your dictionary and send the key value pairs as individual values. right? That is the way. That is what this double star doing. It'll take this dictionary, it will break down the dictionary structure and send these values as key value pairs, individual values. So we are sending like this, but internally how it goes is, right, we are sending like this for convenience. Internally how it goes is host name is equal to device dot host name. Username is equal to device dot username. Password is equal to device dot password. This is how it goes inside. Okay. Hostname is the parameter which is expected by connect method. Hostname, username, password. Device dot hostname is this. This is device dot hostname. So this value goes in. Device dot username. This value goes in. Okay. So either I can do this or I can do this. But you see, this is a extra work for me. So instead of this, I'll do this, which will save me some time and effort. Okay. So we will see this in a very while. But otherwise, you'll have to pass port. Port is equal to 22. And then we have to say, look for this is equal to. Now, this has to be done because the connect method is instructed to, by default, assume that there are going to be SSH keys and look for the keys. Where? In the standard location in .ssh folder under the home directory. Right? Now here, there's a network device. We do not have access, or we have not configured the system. So somehow we have not copied the SSH key there. So we want to connect to it using username and password. But my connect method expects me to connect only using keys, and it keeps looking for keys. So I have to say, do not look for keys. By default, your program will look for keys, but do not look for keys because I'm going to pass username and password to you. That's what this statement means. Once you do that, what you get is another logical representation of what? Of this device. You will get a logical representation of this device. We can call that as this. We can say this for details. What we get, we can call it as, let's say, device. Look for cases false because I'm passing username and password. Okay. Let's say if my keys are set up, I do not intend to pass the password. I'll skip this. I'll show you that as well. Or first we can do that. 44 is the server which I just showed you. Listen to this. Password, I don't need. So I'll comment out the password. And I'll simply print out device. This will just print some internal representation. It may not make much sense, but at least we'll know whether connection was successful or not. Sorry guys, today by mistake I forgot to disable waiting room. So people who are getting disconnected are having to wait for a while. I'll ensure to disable it next time. Line number 4. So line number 3, we created a client. Now to this client, we have to tell when you are faced with this kind of a situation, right? Now this is the SSH client that we are talking about. This guy, let's say he takes this. Right, this is the client. Now he is going to the server with username, right? And then this is the first time he's going. So he gets prompted like this, right? Now, same situation, imagine Python is taking this command, right? With the details which we have given, what is the username, what is the host name, what should be the password, so that it won't prompt us. It will directly take those details and connect. But then it is facing this, it is coming across this. That's what we are saying here. Right? If you come across that kind of a situation, auto add says that go ahead and click yes there. Go ahead and take that key, add it to your known host, so that every next time onwards it will not be prompted. That's the meaning of this. Let me go ahead and delete this and show you what happens if I don't do this. Right? I'll comment this line. I'll say do not add, do not auto add. Let's see if it succeeds. Okay. I do not have my known host entry made for the host, so it will ideally prompt for this kind of thing. But I have not instructed Python what to do, how to deal with the situation. Let's see what happens. So you see, it is saying server this guy not found in known host, right? Missing host key. Missing host key. It is trying to look for this server which I'm trying to connect to in my known host, and it is not found. So it is throwing error. Now I'll understood. This is clear. This statement is to take care of known host file. Okay. Now I'll run this with this. No authentication methods available. SSH exception. No authentication methods available. It is supposed to look for keys. And my keys are added. It is supposed to. Yeah, that's my intention. Password. It should not expect me to pass the password. I'm planning to use the keys because my keys have already been set up. Okay. I'll look into that later. For now, I'll enable my password. So it is saying none because the connection has failed, right? Because it was looking for keys there. So I like to say look for keys equal to false. Still none. Why? Because this 150 Cisco. $190 to $168 to $1. Cisco is correct. DEVASC is for. Yes, it is ISO iOS device. I'll just explain what all this means. Let's see why this connection is not working first. And 90. I'm not using time as such. Let's see. Let's take it out. Anyway, for this, oh yeah, I'm getting data. Look for this. This is .exit command. Lines. This. It's supposed to be an object. Ah, that's why this saying none. Saying none type. It's not really time. Why is this happening? This SSH client dot connect. Okay. I was in the Netmico mindset. Paramico does not return an object. Right? SSH client itself becomes that object. And that's why it keeps saying that is this. And, okay, so basically this is the way we establish a connection. We created a SSH client here by calling paramico.ssh client, and then we saw what happens when we miss this set missing host key policies, right? It complains about known hosts not having this thing. So we have to add this. Once that is done, yes, this entry is made into known host, and we can define a command as a string that needs to be sent. But we'll come to that later. But the first establishing connectivity is use the client which we have created above, that is similar to your terminal, and then use the connect method, and then pass these details and say port 22 and look for cases false. So that because you are saying password, you're going to pass password. So let's see what happens if I skip this. Okay, in this case, it's not a problem. It's reading the same. std std.stdf messages don't exit command. Somewhere here it is coming. Out. Okay, I guess Paramiko works with, no, it is not supposed to. This one. Yeah, anyway, we can use it if it complains. It does not complain, fine. Okay. Good. No, it's not working. Nice. We'll just check about it. That has nothing to do with this time thing. We'll just check. Okay. Sorry about that. Create a client. Take care of this. Define your device details. Define your command. Call the connect method. Pass the dictionary. Right. Pass the dictionary, and then we have to say when you pass the dictionary, this connect method cannot break the dictionary itself and get those details. So you say star star, so that this is known as unpacking, right? Unpack your dictionary and send the details inside. Set the port. This we'll see. Okay. Once that is done, don't need to really print this. Right? We can call SSH client execute command, right? A method we called is execute command, and then pass the command, which is like a string. Now, once you do this, it returns you three things. One is std in, std out, std err. Std in is like if there are any data that's to be passed. Std out captures the output of this command. Std err captures the error in case there is no response, that some error has occurred. There is no response that is coming back, but the error that is coming back, right? So this was like a very primitive implementation. So they have complicated these things. So as we are going to see, we'll be seeing it a more improvised version with the NetNico, how easy to do these things. So from these three things, assuming that our command was successful, our output goes and sits in std out. So we have to take that std out. These are like files, right? Std in, std out, std err are files which are created internally. How do we read data from files? Using read lines. So we'll say std out dot read lines. That gives us lines as a list, which is what we are seeing. These. You see, this is a list notation, and all the lines are printed. A better way to print these lines is by looping through this list using a for loop. I'll say for line in lines. Line is my temporary variable. Print line. Okay, my entire show run output got printed, but you see there are some extra lines that have come in between. That's because print by default prints and takes the cursor to next line, right? And this output also has a inline new line characters inside it in them. So that is resulting in two new lines being printed. This can be avoided by telling my print method, after printing, do not take the cursor to new line. Stay in the same line. Right? By default, end it does this. I'm saying don't do that. Stay in the same line. Which results in a much more well-structured output, which we all know. ISOV, I think I have a link where someone has shared all the images, every image that you need under the earth in a Google Drive. So I'll try to fetch that link. It should be lying somewhere. I'll try to get that link to you. Yeah, okay. Okay, I'll look into this error, but hope you got the thing. We connected via SSH using IP address, username, password, and executed a command. Now let me see what this funny error is about. Okay. Do you need to practice that lab in VM? Yes, it will be. I mean, the VM which you got from IP route, it has all these things, but you need to set up each separately to install these devices. Right? Like this, I have these devices. This is the one, R1, which we are trying to connect to from there. 50. Okay, let's see what that is. Okay. Okay, got it. Yeah. stdin is a file that gets opened. So we'll have to manually close it because we are. So since it's open, it is doing that. Sure. Okay, that funny error is gone. Otherwise, another thing that someone suggested. Now, time.sleep, right? Time.sleep is used. Now, what is happening is we are executing this command. We're executing this command. This command might take some time. Sometimes Python might wait for it. It might not wait for it. Sometimes before this command got a chance to finish, Python will start executing this command. It will start reading files, reading lines, and then throws an error. In such cases, we put a sleep. We ask Python, okay, calm down. Command is still executing. Normally 5 seconds would not be required. A second or 2 seconds at the max should be sufficient. It will say time.sleep. So that's why we import time. In case we are explicitly using time, right? We have to import time. Otherwise, that in the previous case, it was being internally used. So we don't have to do that. Okay. But there's a useful thing to have to when you don't know, the devices might be busy. If they may return the output immediately or may not return the output immediately. So it's a best practice. It's a good practice to just put a couple of seconds of sleep before you actually start reading the data. Okay, this error is primarily coming because of this. It has nothing to do with the time. Yeah, now it is gone. That error is gone. Okay, so that's the funny thing about it, right? This STDN, we are not actually using it. Internally, it is being opened, so we are forced to close it. So that's the little tricky thing about Paramiko, which is a very primitive implementation of SSH this thing. So someone thought, okay, anyway, we'll come to that details later. Okay, that's the way we go about executing. Create a client, exit command. Use the exit command method, pass the command. Once you do that, you will get 3 things: STD in, STD out, STD air. STD out to contain output, STD air in case of any error messages, STD in, I'm not sure what this does. I have to figure it out, but yeah, one thing is we should not forget to close it. And then, as a best practice, sleep for a while and then start reading the data. You can either display the data or you have your tools now, right? Python functions. You can write this to a file, which acts as like your backup. Right? Yeah. So that was about read command. Now, how do we how do we give config commands? Because config commands usually have to give in succession, right? One command does something, changes mode or takes you to a different prompt, and then further commands follow. And let's say you are deep inside the interface, to be able to save the configuration, you'll have to come out, and all that sort of thing have to be done. So in such cases, instead of simply taking the client, we say, take the client, get that guy's shell, invoke shell. There's a method called as invoke shell, so that a shell, a logical representation of the shell is returned to me. On that shell, I can go on giving multiple commands. Right? So I'll take that and keep sending, send this, send this, send this, send this. So I said multiple commands for config commands. And then at the end, once I'm done with all that, I'll put some sleep and then say, okay, now I'm done with sending all the commands to the shell. Now receive the data from there. Okay, we'll do this. Okay, import parameter, import time because we might have to sleep. Client is equal to, what do we do? Parameter dot SSH client. Right? This is a Python class, so we have to end it like this. This creates an object and puts it in this. Then we can define host name. I'll define as individual strings now. Thank you, 168. Username. I'll take this client dot connect. So I'll pass host name, username, password, port is equal to 22. Right. What did I put? That's the one. Is a typo. Yeah. Now the connection is successful. So there's another way to, if you want to pass the values individually, you have to pass them as named arguments, named parameters. Post name is equal to, either you can put this directly, or since we stored in this variable, we are passing them as variables. So you see the other way was much simpler, putting in the dictionary and directly passing the dictionary. Now we want to send multiple commands, so we'll say, okay, get me a shell, right? Instead of sending an individual command, so I'll say establish connection. Connection is equal to client dot invoke underscore shell. So once I have that connection, I'll start sending commands. Con dot send on, because the connection will take you till the prompt without getting into the enable mode, right? No, it will take you to the prompt in an enabled mode. But you'll have to get into, you'll have to do all the further actions like enable, configuring, getting into the config mode, and so on. Dot set. You see, the thing with this is I have to give this also, exact commands. It's like hitting enter. Okay, go to new line. Come out, save the config. Okay. So this is enough if you just want to perform. But let's say you also want to see output. Then we have to say connection dot receive. And con dot receive. The funny thing with this is we have to say how much to receive. So we have to pass some value. Now we don't know how big it is, right? We say get me whatever is there, 65535. That is like 2 power 8. Yeah. Whatever is there, the maximum size, whatever is there in the buffer, just dump everything. And we also have to say that will be stored in a binary format. So before sending it, decode it into ASCII format and then send me. Right? So all this we have to say. We have to say dot decode in ASCII format. ASCII is character format. That I'll be storing in a variable, let's say output. That output I can put. And this much we have to do. Invoke shell, get the connection, using the connection, start sending multiple commands, config commands, but you'll have to take care, okay, whether I'm getting into config mode, and then before giving write command, whether I'm coming out using the end command and so on. Otherwise, you will get unexpected results. And after executing, you have to call the receive function and specify the size of the buffer, how much data to receive, this being the maximum, and then decode it into ASCII format. That's when you're going to go and get your string output. That happened because I forgot to put sleep. Right? It got my output and came out by the time whatever was there. But if I actually go onto this thing, I will be able to. How do I delete it? Okay, it is 1. What did I give? Actually, didn't go and get created. So I got this partial output because I forgot to sleep before getting the output. So I'll say time dot sleep. Let's say 3 seconds. Formatting. I don't need format because I do not have any variables. Right? I'm setting all the hard-coded values. Bad IP address are hosting, so that's what is big. IP address. Yeah. It's cool. So that was successful. You can see here. Okay, so get the shell, give the commands, but these are the some painful things. You have to remember to give view line at every command. And after giving all the commands, you'll have to sleep for a while so that if you, of course, you don't have to unless you want to see the output and then receive the output using this function and then decode it into ASCII. That's where you'll be able to see, go and see your actual output. Okay, that's how you send your config commands. Okay. Now, some of these things have been taken care, have been improvised by NetMiko. So there is a lot of scope for improvement, but yes, still it is much better compared to Paramiko. It's more intuitive and it is aimed at network devices. Right? Whereas Paramiko was pure SSH implementation, so which supports both Linux devices, Linux servers as well as network devices. NetMiko was created specifically for with network devices in mind, and hence they can support different types of devices. Which, if you go to NetMiko website and see, they have categorized all the devices as regularly tested. We keep these are like devices on which we'll keep testing regularly and so on. Like 4 different categories: frequently test, regularly tested, once in a while tested, trial devices. Like okay, they tested once in sometime in the back. It was working at that time. After that, they have not tested, so we cannot guarantee whether it will continue to work on those sets of devices. So like that, they divided the class devices into different classes, right? So out of this, these devices happen to be like the ones which they regularly test and support. getting started with NetMiko is same pip install NetMiko or Python 3 or Python -m pip install NetMiko. Once that is installed, we'll be able to import NetMiko, or we would not be needing whole of NetMiko. NetMiko has a lot of other things. So if all we are trying to do is just connect to the device, get our work done, we can specifically say from NetMiko import something called as connect handler. As the name suggests, this is the guy who handles your connection. And then we have our device details defined. Right? Now, one extra that we need to specify in case of NetMiko is what is the device type. Right? Because NetMiko is a multi-vendor library. It can support, it can work with different types of vendors. So you need to specifically tell which type of device you are trying to connect to, so that it can load that part of that module, and then it can create that flavor of client, and then give it back to you so that you can work with that device. That's the only difference. In Paramiko, we used to create Paramiko.ssh client. We used to get the client, and to that client we used to pass the details. Here we can directly say this has been pre-created for us. We'll simply say import it, and pass the details, device details to this. And you see here, all that headache is taken care. Your SSH connectivity, nitty-gritty details are taken care. I don't have to worry about taking care of missing host policy. It has been internally taken care by that. I don't, of course, previously the look for keys was not working. Somehow it was working well and good. It has changed since then. But even if such a thing is not required in case of NetMiko, we can directly say connect, and then just pass the details. Just pass the connection details. The bare minimum connection details required are this: device type, IP address, username, password. And since I said it is a multi-vendor library, they'll print the type of the device which we have connected to. So it should show something like, okay, we connected to Cisco iOS. Okay, let's see that. NetMiko is already there. Okay, what are the things to be done? First thing is install Python -m pip install NetMiko. Okay, already there. Next thing is import NetMiko, or we can say from NetMiko, because I don't need whole of NetMiko. From NetMiko, import connect handler, C capital, H capital. Okay, once I have the connect handler, I can define my device. Here also you have the same both two options. Either you can put in a dictionary or pass the dictionary, or you can give them as individual values. Obviously, this is better, right? First thing is device type, device underscore type. These are again Cisco iOS, iOS XE, iOS XR. All those things are like predefined values. We'll have to check the NetMiko documentation to see what all device types are supported. Right? I cannot simply give ABC XYZ here. It has to be a valid device type which can be identified by network. Comma host, is it host or IP address? IP, it is IP. Okay, once I do this, I can directly say connect handler dot connect. No. Okay, directly pass the details. Star device details. Now the thing with this guy is he returns something, right? He returns an object. So we have to store it in a variable. What does he return? He connects to the device and returns the logical representation of your device. So it's appropriate to call this guy as this variable, name this variable as device, because what we get back is a logical representation of the device. So let's say first print device. It should show some internal object. Print type of the device. So you see it's so smooth. With this, let me go. What is the object that it has created? Is let me go Cisco iOS. Within Cisco iOS package, it took Cisco iOS SSH. SSH specific implementation for Cisco iOS. Right? This object represents Cisco specific SSH implementation. What are bytes? And this is the type of the object that is created. Okay, now all we have to do is device dot send command. Is it send command? Yes, send command. Send underscore command, and it will start giving you commands. Another thing is I don't have to have that STDA in STDR, STD out, then take STD out and read lines, etc., etc. Directly it is returned. Output is returned to me as a string. I can simply print that string out. So this is another improvisation that has been done on top of parent code. So I'll say I'll be sending some command, but let me capture the output in this. And what's the command that you're sending? Device dot send underscore command. If you want to send, single command. Once you send the command, you get the output. Check the output. Okay, pretty neat, right? I don't have to worry about formatting. It just takes that command and then simply gives me in the same format. Okay, which I can directly put it to a file if I want. So let's say show run. See, I don't even have to worry about printing new lines, taking out new lines, etc., etc. Okay. Now let's say you have multiple commands to send. You can say send commands. Yes. Send config set. Though we are calling it as config set, we can still pass the read commands also, because typically show commands we give in single commands, whereas config commands comes in batches. So that's the reason probably they named it that way. But nothing's stopping you from. Okay, it is taking you into config mode, because you are using config set, so you'll have to do 2. Okay. The moment you say, okay, call this function send config set, it takes you into conft mode. Yeah, that was the thing. So first thing is send command. If you want to send a single commands, the 2 read commands, you have to use send command. Now send command takes you to enable mode and then gives you the commands. So obviously from there you cannot give config commands, because you will not be able to send command by default will not take you into this thing. Of course, there is a way you can do that. How to put output in a new file, right? We have that. Right? With open output.txt. So this is the name I've chosen to create my file, and then I'll say create this file in write mode, as I'll give some name to this handle out file. Out file dot write output. don't need this. So you have your output.txt with your both the command output. It's as simple as that. With open file name, which mode we are trying to write. So write mode as some name with some name dot write or to write. How to go into config modes? Yes, we have commands for all of that. Now read the docs. Go to the read the docs. You can check which prompt you are at. And this is the list of commands. Enable mode. Yeah, enable. Right. SSH dot enable will, assuming that you're not even in an enable mode, this function will take you to enable mode. Let's say you want to come out of enable mode, you can say enable. Exit enable mode. Sending commands. Send command will help you to send one command. Send config set will help you to send a list of commands in config mode, which means you will directly get into conft mode. Now send config from file. Instead of defining them within your code, just like how I've done, right here, I'll put my commands in a list. Instead of this, I can put them in a file. If I have them in a file, I'll say send config from file and give the file this thing. Then this is if you want to put some timer, right? Let's say you don't want to give immediately. You want to give one command, let that finish, or let's say that waits for some time. You do that, wait for some time before giving the next command. Then you have config mode, right? Specifically, you want to switch into config mode, right? And then exit config mode. You want to exit, come out of config mode. And prompt, find prompt, right? So this will help you to find which prompt you are at. If some devices require you to commit after you give certain commands, right? Commit method will help you. At the end, let's say you just want to terminate, disconnect. There are other methods. Okay, so this is Python for network engineers. So useful reference. Keep this as a handy reference. Posting in chat. So they have even covered the Python basics. So you can use this as a refresher. Some useful stuff about how to take the password input. Some modules, some useful modules. Paramiko, Netmiko, Scraply. We do not have it. We have Paramiko and Netmiko. You can read up the other tasks out of your interest. Object-oriented programming, working with databases, all that has been covered. Okay, going to source private message. Let me send it to everyone. Okay, so I can create a file, commands.txt, and put the same commands. Show work. Run. It's got this. So send config from file. Hope that is the correct. Send config from file and the file name. Right. So this takes these commands and then executes them, gets output. Send config from file is not defined. Send config from file. Obviously, it has to be called on device. Off shortly. Yeah, obviously the commands have to be good. Now I cannot use the other command here. We have that handy command exit config mode. Right? Probably I can do that. I can put that as no. That's a method. I cannot. So I can say exit. I put an exit here because it gets into config mode as soon as it goes in. And then promptly I can do this. Let's try that. Yeah, that works. Okay, since I'm using send config set, it takes me to conft mode. I do an exit, come out to enable mode, and then give these commands. But ideally, I mean, this is more useful for giving the config commands, right? The face, blue, back, 20, 20, like this. So I'll have to come out. Okay. WR. Okay, that's my output. Configure terminal. Enter config commands one per line. Interface to guide 20. You see, all that output has gone into my output.txt, whatever I have done. And you can actually see the prompts changing and so on. And my configuration is done with my loopback adapter. Okay, send command, send config set, send config from file. So if you get the hang of it, right? Okay, which method takes me into which mode, then you can play around with it, right? I used send config set, so it took me into config mode. But there, let's say if I want to give read commands, either I have to use my do with the do, or I can come out using exit and then do the rest of the stuff. Okay. Okay, everyone. Thanks. That concludes Python as we planned it. From Monday, we'll start with the Ansible. And by the way, tomorrow we'll not have class, so I'm still not fully on that.